Jai Hind viewers, welcome to AKGEC Digital School. My name is Pankaj Singh, Faculty of IT Department. Today I am going to deliver my second video lecture on a topic of operating system, that is process, state and process scheduling. So now have a look over the outline of a presentation, means what we will going to discuss in this video lecture: definition of a program and a process, different process states, what is PCB, process scheduling queue, and type of process scheduler. Now let us start. As we all know that what is a program? Computer program is a sequence of set of instructions in a programming language for a computer to execute. It is a basic definition. Secondly, we also say that a computer program in its human readable form is called source code. And if we talk about what is process, a process is defined as an entity. Here I give a stress on a point, entity. Why entity? Because it changes from one state to another as we go to the next slide, when represent the basic unit of work to be implemented in a system. Or in a more technical form, we can say a process is a program in execution. The running program is known as a process in a execution form. The execution of a process must progress in a sequential fashion. Means first process will break down into different states, or we can say it will go to the different sequential processes or methods till the execution. Means when we give a program to the execution, when we input a program, during the execution phase, there are number of different states are going through by a program. These different state is represented their status in a current fashion. So now we have to understand what are the components of a process. Component of a process contain a object code, as I said, written in a specific computer language. Okay. What is data? The data is used by the memory, or we can say we pass a different data type that is required to execution of a required program, and we also use different resources to execute a program. For example, we require resource R1, R2, R10 to execute process number 2, and we have number of resources required for a program P3, process 3 required resource R2, R11, R10. So the different parameters required to execute a program: object program, it is a code written in a specific language. Different data to be used for execution of a program require different resources, and it also represents the status of a process. Verify the state of the process execution. A process can run to the completion only when all the requested resources has been allocated to the process. Two or more processes could be execute the same program, each use their own data and resources. Same program may require different data set, or we can say different data to execute and different resources, but program may be same. Now it is a process state diagram in which we can see over the screen as a process execute it change its state. So as I said, when we input a program, to CPU to execution, it will give output. So during the execution, it will go to the given 5 state. What are these state? First one is new, it is the first state. Second one is ready. Third one is running. If program in a running mode, we can say it will go to the fourth, or either if the required resources is not available to execute the program, it will go to the waiting state. So after this, the state may be this one or this one. Okay. Now have a look over there working over by the help of given slide. When we entered or generate a process or program, it will consider as a in a new state. And when a process is waiting for a operating system for their execution, or we can say for a processor for their execution, it will lie into a ready state. And when a process is actually executed, it's known as its running state. And if a process is not run because of non-availability of required resources to execute a process, it will go to the waiting state. And if it is run by the help of or required resources, it will go to the terminated state. Now we have a exact definition or work of their states. What is new? It represents the process is being created, or when it is assigned to the processor. What is ready state? The process is in waiting to be assigned to a processor, is known as ready state. What is running state? Process instruction are being executed. During the execution state, it is known as running. And if process is waiting for some event to occur or waiting for some resources, is known as waiting state. And as we all know what is terminated, the process has finished its execution and hand over result to the required application or to the user. All these detail of a process is managed and controlled by the PCB. What is PCB? Process control block. I am going to the brief introduction about definition PCB. Each process is represented in the operating system by the processor control block PCB, called as a, it is also called as a task control block. Means it operate all the operations regarding a process, and it contain its detail in a uniform manner. And what this field contain? PCB is a data structure used by the operating system. Operating system group all the information that need about a particular process. What field a PCB contain? PCB contain pointer, process state, process number, process counter, CPU register, memory allocation, event information, list of open files, and so on. So, if we talk about pointer, pointer keep the information about the next process to be execute within a PCB block, and the current state of the process, either it is in a new, ready, or in execution, whatever is the state of a given process. Process number, as we use in general, P1, P2, P3, but in a system it is a unique number assigned to each and every process. After that, a program counter, as we all know that PC program counter always point out to the current execution that is running within a machine. The different registers used to carry from where the information is taken or information is temporarily stored is also defined in a PCB, memory allocation, event information, and list of open files related to the current process. All such details is kept by the PCB. These are the fields what it kept: pointer point to the another process. Control block pointer is used for maintaining the scheduling list, the next process that will be going to execute. And process state may be, as I said earlier, it represent its current state. It may be a new, ready, running, waiting, and so on. Program counter indicate the address of the next instruction to be executed for this process. CPU registers use GPR, stack pointer, general purpose register, stack pointer, index register, AC, ALU operations executed by the help of accumulator register. Likewise, memory management information. This information may include the value of base and limit register. This topic is going in detail when we go through the paging and segmentation in a memory part. How to make the pages, how segmentation is executed. So, these things we will discuss in a third unit when we will go for a memory management. Accounting information, how much OS is used in real time and all their usage is kept into a PCB. This information include the amount of CPU and real time used, time limit, job and process number, account number, etc. So, accounting information exactly contain the usage of CPU in term of real time, what time is assigned to a process, time limitation, job and process number and account number, etc. In this method, we required process scheduler to schedule all these processes so that they can execute in a sequential manner without disturbing their order, or we can say to manage all these things, it is done by the help of process scheduler. So, before going to the process scheduler, we must know what is process scheduling. The process scheduling is the activity of the process manager that handle the removal of running process. Exactly what happened when we number of different processes running within a machine, the order may be changed as per the instruction by the CPU or by the user if it is changed on the behalf of priority. Second, from the CPU and the selection of another process on the basis of particular strategy. If strategy is changed, the order or the execution of a running thread may be changed. Third, process scheduler is an essential part of a multi-programming operating system. Such operating system allow. Before multi-programming operating system, this feature is not available. We cannot change the order of the process execute within a system. In the previous mode, when multi-programming is not achieved, or we can say is not implemented in a OS, we can't change the order of the executing process. But in this mode, we can easily reschedule, or we can say assign the priority, or we can suspend the current running process and allow to execute to the next process. Next point, more than one process to be loaded into the executable memory at a time and loaded process shared the CPU. So, when CPU we can use in this method in a switching mode, like at a time P1 and P2 is executed, as we all know that in a primitive mode on behalf of their burst time. Using time multiplexing also prefer. Next, What is scheduling queue? In scheduling queue, all the processes queue back to back each other. Scheduling queue refer to the queuing of the process or devices when the process enter into a system. It is maintained. This process is put into a job queue. This queue consists of all the processors in a system of operating system. It also maintains other queues such as device queue, waiting for a particular IO device. Each device has its own device queue. So, first of all the processes that will execute is scheduled by the process scheduler, and it is done by the help of scheduling queue. All the processes maintained in a queue, and that is done by the help of scheduling queuing. This process is put into a job queue, and each device have its own device queue. Means number of devices connected to the system is managed by each and every devices by its own level. Like IO devices connected to the to the machine is managed by the given scheduling queue. Here we have a diagram of scheduling queue. As we see, I read to the point what written here. This figure shows the queuing diagram of process scheduling. Queue is represented by a rectangular box. All the rectangular box represent different queue. The circle represents the resource that serve the queue. What are the resources here? CPU and IO devices. The arrow indicate the process flow in a system. How the process will pass through these resources, it represent by the help of arrow. As we see in a given scheduling queue diagram, when a request is passed to the machine, it will move to the ready queue and pass to the CPU. But if concerned process required some more IO devices or memory access, it will again go to the IO request mode. It will again IO queue. As I said into a previous slide, each device maintain its own queue. So, request go to the IO queue. Similarly, at the same time, if it is lie into a time slice category, it will go direct to the ready queue and again queue for the execution. And there may be a one case for a child execution mode, and one is wait for the interrupt mode. And finally, going through all these processes, or we can say different state, it will again go to the ready queue and execute, going for execution on a CPU and exit in a termination state. So, the ready queue basically execute all the instructions or all the processes go to the CPU, but it may change their waiting state on behalf of their requested resources. It may be in request of IO devices, may be not available at that time. It will go to the IO devices, it will maintain its own queue, go to the IO and again queue for the execution. Similarly, the time is as said in a previous slide, it use time multiplexing for the execution, for a child and waiting for a interrupt. So, these are the different execution mode of a process, or we can say a waiting mode of a process, but finally they can again queue and this process will repeated till the execution of a last process. For example, we have P1, P2, P3, P4, maybe P1 execute, P2 go to the request IO devices, any IO device is required, P3 maybe time slice, P4 maybe a fork of a child, and it will again queue in a ready queue and pass to the CPU for the execution. So, process is executed by using ready queue mechanism using in a process scheduling. Thank you.